We have the following objectives for today's lesson. Define permutation, find the permutation of n objects taken r at a time, and solve problems involving permutation. Let us have a brief review on factorial notation. The symbol n exclamation point, read as n factorial, is used to express products such as n factorial equals n times n minus 1 times n minus 2 times n minus 3 times 2 times 1, where n is any positive integer. So the rule is n factorial equals n times n minus 1 factorial. This means that the factorial of a number is the product of its components. For example, 1 factorial is equal to 1, 2 factorial is equal to 2 times 1 equals 2, 3 factorial is equal to 3 times 2 times 1 equals 6, 4 factorial is equal to 4 times 3 times 2 times 1 equals 24, 5 factorial is equal to 5 times 4 times 3 times 2 times 1, which is 120. You have to take note that the factorial of any number is that number times the factorial of that number minus 1. For example, 10 factorial is equal to 10 times 9 factorial, 12 factorial is equal to 12 times 11 factorial, 24 factorial is equal to 24 times 23 factorial, and 30 factorial is equal to 30 times 29 factorial. Let us consider that 4 pictures are to be arranged from left to right on a wall of an art gallery. How many arrangements are possible? So this means for the first picture that we have 4 ways of selecting the first picture. After selecting the first picture, it means that we only have 3 ways of selecting the second picture. For the third picture, we only have 2 ways of selecting the third picture. And of course, we have single way for selecting the picture 4. So it means that we have 24 ways of selecting the 4 pictures. This kind of arrangement of things in a definite order with no repetition is called permutation. The number of permutations of n objects taken all at a time is denoted by the following notations. So this one can be read as permutation of n taken n at a time, which is equal to n times n minus 1 times n minus 2 and so on up to 1, which is also equal to n factorial. Let us consider this example. How many different 4-letter patterns can be formed using the letters R, S, T, and U if a letter cannot be used more than once? So for the solution, our n is equal to 4, so we will be using the permutation of n objects taken n at a time equals n factorial. So it means that we need to substitute the value of n into 4 factorial, which is equivalent to 4 times 3 times 2 times 1. So we have 24 ways of arranging our letters. For the second example, in how many ways can 5 books be arranged on a shelf? For the solution, the value of n is equal to 5. So we will be using the formula permutation of n objects taken n at a time, which is equal to n factorial. Substitute the value of n into 5, so we have 5 factorial, which means that we have 5 times 4 times 3 times 2 times 1. It means that we have 120 ways of arranging our books on a shelf. Let us consider another example. Suppose that in a beauty pageant, there are 6 finalists. How many ways can 3 winners be selected? So we can determine the number of ways this finalist can be arranged in a row if we arrange only 3 of them at a time. So the first winner can be chosen in, of course, 6 ways. The second winner can be chosen in 5 ways. And the third winner can be chosen in 4 ways. So it means that the permutation of 6 finalists taken 3 at a time is denoted by the following notations. So we have the permutation of 6 objects taken 3 at a time is equal to 120. So it means that we have 120 ways of selecting our winners. We can also express our solutions in terms of factorials by multiplying 6 times 5 times 4 times 3 factorial divided by 3 factorial, which is also equal to 6 factorial over 3 factorial. So this one denotes the permutation of n objects taken r at a time. The number of permutations of n objects taken r at a time, where n is greater than or equal to r, is given by n times the quantity n minus 1 times the quantity n minus 2 up to times the quantity n minus r plus 1. Or it is denoted by permutation of n objects taken r at a time equals n factorial over the quantity n minus r factorial. Let us consider this example. In a horse race, how many different finishes among the first 3 places are possible for a 10-horse race? So for the solution, n here is equal to 10 and r is equal to 3. Using the formula, permutation of n objects taken r at a time equals n factorial over the quantity n minus r factorial. Substituting the values of n and r, we have 10 factorial over the quantity 10 minus 3 factorial. Simplifying the denominator first, so we have 10 minus 3. Then we have 7 factorial. So we have 10 factorial over 7 factorial. So we can express the 10 factorial into 10 times 9 times 8 times 7 factorial. And then canceling the common factors, or 7 factorial, then we have the 10 times 9 times 8, which is 720 ways. It means that we have 720 different finishes among the first 3 places. Let us have another example. Ira has 9 books, each of different subjects. How many ways can she arrange the books in a bookshelf that holds only 5 books? So for the solution, n is equal to 9, the value of r is equal to 5. So we will be using again the formula n factorial over the quantity n minus r factorial. Substituting the values of n and r, we have 9 factorial over the quantity 9 minus 5 factorial. Simplifying the denominator, we have 9 minus 5 factorial, which is 4 factorial. And then we need to express the 9 factorial into 9 times 8 times 7 times 6 times 5 times 4 factorial. Canceling the common factor, which is 4. So we have 15,120 ways of arranging our books. Try doing this on your own. Until our next session, thank you and enjoy learning.